Welcome to video 2 out of 6 on Alberta Science 9B4 Chemical Nomenclature. In this lesson, we will be looking at the IUPAC names for common chemicals. The specific learning outcome for this is that students will read and interpret chemical formulas for compounds of two elements and give the IUPAC name and common name of these compounds. Introduction. Understanding how to read and interpret chemical formulas is an important skill in chemistry. Chemical formulas tell us which elements are present in a compound and how many atoms of each element are involved. In this video, we will focus on compounds made from two elements, also known as binary compounds. Binary meaning two, that bi like in bicycle means two. We will learn how to name these compounds using the rules set by the International Union of Pure and Applied Chemistry, IUPAC, and we will also look at their common names. A chemical formula is a shorthand way to show the types and numbers of atoms in a compound. For example, the formula for water is H2O, which means it contains two hydrogen atoms and one oxygen. That subscript, or that lower level 2 after the H, tells us that we have two hydrogen atoms. Oxygen does not have any numbers, so the 1 is implied. So 2 hydrogen, 1 oxygen. In this section, we will look at formulas for compounds made from only two elements, such as sodium chloride, carbon dioxide, and magnesium oxide. So the types of binary compounds. Binary compounds can be divided into two main types. Ionic compounds. These are formed when a metal reacts with a nonmetal. The metal loses electrons to become a positive ion or cation, and the nonmetal gains electrons to become a negative ion or anion. These ions are held together by electrostatic forces. Molecular or covalent compounds. These are formed when two nonmetals share electrons. The atoms are held together by covalent bonds. If you recall from the previous lesson, ionic compounds, one of them will give up an electron and just hangs around but is not particular about which other ion it's hanging around by. Whereas the molecular ones, because they share the electrons, they are tightly bonded to each other. So reading a chemical formula. When you see a chemical formula, you should be able to identify the elements present using their chemical symbols, the number of atoms in each element using subscripts, the physical state of the compound. So there'll be little italicized letters after them in brackets. S for solid, G for gas, L for liquid, and AQ for aqueous, meaning it's been dissolved. So if you pour salt into water, stir it up, and you can no longer see the salt, that salt is aqueous. It is not actually a liquid, it is suspended in water. For example, in CO2, the C stands for carbon. O stands for oxygen. The subscript 2 means there are two oxygen atoms. C does not have a subscript, so there's one carbon in each molecule. G would mean the compound is a gas. For ionic compounds, the name is made up of the metal, or the cation, followed by the name of the nonmetal, the anion, with the ending changed to IDE. For example, sodium chloride, NaCl, Na is sodium, that's a metal. Cl is chlorine, it's a nonmetal. The name is sodium chloride. We change that "ine" to "ide." Oh, and I should have mentioned, see there's no bullet for it, but that subscript S makes it a solid. Example 2, magnesium oxide. Mg is magnesium, the metal. O is oxygen, the nonmetal. The name is magnesium oxide. Again, we end with "ide." That S means it is a solid. Some metals can form more than one type of ion. For these, we use Roman numerals to show the charge of the metal ion. In example 3, iron 2 chloride. That tells us that iron will have a 2+ charge. That's what that Roman numeral 2 means. So Fe is iron. Like sodium, the name comes from a non-English language, so the letters don't always make a lot of sense and just have to be memorized. Cl is chlorine. Iron can have a +2 or +3 charge. In FeCl2, iron is +2. So the name is iron 2 chloride. We know it's +2 because chlorine can only take the -1 charge. We don't see any markings of charges, so they have to add up to 0. So the iron has to perfectly balance the chlorine. If we have 2 negatives from the chlorine, we have to have 2 positives from the iron. Another example, iron 3 chloride. Notice now we have Cl3. Fe is still iron, Cl is still chlorine, and FeCl3, iron is the 3+. We give it that Roman numeral 3. We know it's the 3 and not the 2 because it balances 3 chlorines at -1 each. For molecular compounds, we use prefixes to show how many atoms of each element are present. So the prefixes are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6. There are more, but these are the ones we'll deal with in this course. The first element keeps its name, and the second element's name ends with "ide." So example number 5, carbon dioxide. C is carbon, O is oxygen. There are 2 oxygens, so the name is carbon dioxide. The di prefix meaning 2, and it ends with "ide." Nitrogen trihydride. Well, we have nitrogen and hydrogen. The tri tells us there's 3. This is ammonia. So N is nitrogen, H is hydrogen. There are 3 hydrogen atoms, so we use the prefix tri. We end hydrogen with "ide, so we have nitrogen hydride. Example 7, carbon tetrahydride, better known as methane. So that 4 matches the tetra. C is carbon, H is hydrogen, and there are 4 hydrogen atoms, so the name is carbon tetrahydride. And there are some common names as well. Some compounds have common names that are used more often than their IUPAC names. For example, NaCl is sodium chloride. Common name is table salt. NH3, nitrogen trihydride, more commonly known as ammonia. Carbon tetrahydride, common name is methane. You will find that for some gas burning appliances. It is important to know both the IUPAC and common name, as both are used in science and everyday life. So we'll try naming a few. CO is carbon monoxide. We use the prefix to say there's 1 oxygen atom, and change oxygen to oxide. H2O, dihydrogen monoxide. The common name is water. If you go to dhmo.org, you will find a website that often tricks people who do not understand this element. CaO is calcium oxide. Notice that the A is lowercase. Any elemental symbol on the periodic table always starts with a single capital, so that tells us the A is part of the C. It's calcium, not carbon. Also notice, because calcium is a metal, this is ionic, it is not molecular. That's why it's not calcium monoxide. It is just calcium oxide. In conclusion, being able to read and interpret chemical formulas helps us understand what substances are made of and how they behave. Knowing how to name compounds using IUPAC rules and recognizing their common names is a key skill in chemistry. Remember to look for the elements, count the atoms, and use the correct naming rules for ionic and molecular compounds. With practice, you will become confident in reading and naming chemical compounds of two elements. So let's check for understanding. What is the IUPAC name for NaCl? Pause now if you need more time. The IUPAC name is sodium chloride. The common name is table salt. Which of the following is the correct chemical formula for water? Is it HO2, H2O, H2O2, or H3O? Pause now if you need more time. Water is H2O. What is the common name for CO2? Carbon dioxide, carbon monoxide, carbon tetrioxide, and carbon trioxide. Pause now if you need more time. This is carbon dioxide. Which of the following compounds is correctly matched with its IUPAC name? Is it Al2O3 aluminum oxide, CaCl2 calcium dichloride, KBr potassium bromide, or MgO magnesium oxide? Pause now if you need more time. It is potassium bromide. So the aluminum oxide, calcium dichloride, and magnesium oxide are not quite correct in their IUPAC names. Things like calcium dichloride, we don't use the di for ionic compounds. So potassium bromide is the correct one. Given the chemical formula Fe2O3, what is the IUPAC name of the compound? Is it iron 2 oxide, iron 2 trioxide, iron 3 oxide, or iron 3 trioxide? Pause now if you need more time. This is iron 3 oxide. Again, with a metal and a nonmetal, we don't use the tri prefix. So we know it is not tri because it's ionic. And oxygen has a charge of 2- when it's in a compound. So there's 6 negative charges on the oxygen. That means we need 6 positives on the iron. So when you have that Fe2, that means each iron is 3. That's how we get to the iron 3 oxide instead of the iron 2. If you have any questions, concerns, just anything you want to share, suggestions for improving the slides, please feel free to respond in the comments. I will do my best to reply to all of them in a timely fashion.